Effective stress. It is first coined by Carl Tarzagi. He given an expression like this: effective stress sigma bar equal to total stress minus pore water pressure. Okay, it is a non-physical parameter. It means that we cannot measure effective stress with the help of any instrument, but total stress and pore water pressure are physical parameters. It means that we can measure with the help of suitable instruments. Okay, then what is this effective stress? Effective stress is a pressure which is transmitted to the soil grain to grain contact with the help of grain to grain contact. It implies, let's say we have two soil solids like this in a soil mass. We take two soil solids like this. Due to this effective stress, the soil particles, the distance between soil particles will reduce. What it means? It means that the volume of void, this is void, no, the volume of void between these soil particles will reduce. It means volume of voids will reduce. Okay, so we will know from the basics, void ratio equal to volume of voids by volume of solids. As in soil mechanics, note that soil solids are incompressible. It means that they don't compress. Okay, so the volume of solids will be constant. Okay, then E is directly proportional to volume of voids. As due to effective stress, void ratio also decreases, because as volume of voids are decreasing, so void ratio also decreases. Okay, so void ratio decreases, then due to void ratio decrease, denseness of soil also increases, not decreases. If void ratio is decreases, then denseness of soil increases. Okay, this is for dry soil mass. Okay, now we don't consider here, now, right now we don't consider here water. What happens if water is present? Let me clear this up. Okay, chalo. So now same, two soil particles are there, but in between there is water. Okay, we know from fluid mechanics, water is also incompressible. Okay, so water also don't compress. Okay, it means that the contact, grain to grain contact becomes difficult. Okay, it means that due to submergence of soil, effective stress is decreases. So due to soil submergence, effective stress decreases. Okay, so what happens when there is a uniform surcharge on soil mass? Let's take a soil mass like this. Okay, so first we'll stick to dry. Today we stick to dry condition of soil mass. Okay, this is a dry soil mass, so there is only solids are present, no water. So due to uniform surcharge, let's say Q. How can you imagine uniform surcharge means? Let's say you construct a building on the dry soil mass. Okay, so we know that effective stress always act downwards. effective stress always acts downwards. Okay, so uniform surcharge also acting downwards. Okay, what happens like this? If it is a beam, okay, it is a beam, the load acting like this and one more load acting like this. Okay, obviously the load will increase. Okay, so due to uniform surcharge, uniform surcharge also effective stress increases. Effective stress increases. Okay, effective stress increases. So due to uniform surcharge, effective stress increases. Okay, let me clear this up. What happens when there is a capillary saturation? So we know little about capillary saturation. Okay, so water present like this. Before, the submergence is different and capillary saturation is different, very different, both are not same. Okay, even you can see this, due to submergence effective stress will decrease. Okay, due to capillary saturation we'll see, will the effective stress will decrease or increase, we'll discuss. Okay, so capillary saturation means, capillary saturation, it is due to capillarity due to surface tension. It means that the water present here will be in tension, okay, due to this tension there will be compressive forces on soil solids. Okay, so it means that even due to capillary saturation also effective stress increases. Why? This capillary saturation is helping the solids to come closer. Okay, so it means that pressure transmission. Okay, so it means due to capillary saturation effective stress increases. Oh, very good. We want that only, we don't want effective stress decrease, because we'll discuss why. Okay, these cases, now till now we discuss no flow condition. Till now we discuss no flow condition. These are boss, no flow condition. No flow condition. But here seepage means flow. Why flow takes place? If there is a head loss, then flow takes place. It means that there is no head loss. Head loss is 0. Let's say head loss H is 0 here, but here head loss is not 0. Okay, so we know one more thing, what effective stress or vertical stress always act downwards. Effective stress always acts downwards, but seepage can be upward flow, can be downward flow, can be horizontal flow. Okay, it can be anything. Okay, I'll take seepage pressure as PS. Okay, and effective stress, we all know it is represented by sigma bar. If both are, the seepage is taking downwards and effective stress also downwards, then it will increase the effective stress. Okay, if the seepage pressure is, the seepage is upwards, then seepage pressure also acts in upwards, then in this case effective stress will decrease. Okay, in this case effective stress will increase, in this case effective stress decrease. Okay, very good. What happens as the seepage is horizontal? So let's take this is oil mass. Okay, now the seepage is like this. Okay, then always like this effective stress. In this case we know, so it means that the effective stress will act like this, the pressure, seepage pressure act like this. So there will be a net effective resultant force will act in this direction. Okay,